So chapter 14 is all about linear models and linear regression and the least squares. And so what we're going to do here is we're going to take some data points and try and fit it to lines, find the line of best fit. And so the way that we're going to do this is we're going to store our X values. We're going to store our Y values. And then if you want, you can even plot the X and Y values. That'll give you your 3 points. And then you can find the line of best fit here by doing LM for linear model. We're comparing Y to X, and then that's going to give us our intercept and our slope here. And so we want to round to 2 decimal places. So that's going to be 2.23 plus negative 0.46. Okay, and so that's our linear model, and then you can kind of go through it and plot. I'll let you kind of figure out what that line looks like and what those 3 points are. So that's not too interesting to do that. So I'm going to skip that. So same thing for number 3. It's just if you have more data. And then there's one little quirk here with number 3, and there's a quiz question that you have to do this as well. But let's put in 6162 6245. So those are our X values, and our Y values are 250, 400, 245, 350, 280, 370, 335, and 305. Okay, and so here we have 8 pairs of points, and we want to find, so if we wanted to, you could plot the points and see what they look like. And so these look roughly linear. And so we could find the regression equation for these points. Again, the same code, compare Y to X, and then you're going to get 421.5 and negative 26.17. Again, rounded to 2 decimal places. So 421.54 minus 26.17. And that's your linear regression, and we're done. Okay. And so that's how you find the linear regression there. These points are going to look roughly like that. I know that just from graphing the points. They don't do a very good job of giving you good distracting wrong answers there. It's just, anyways, if you think about what the points look like, that's it. And then here, as the price, as the age increases, the price decreases. So the price decreases as age increases. Fine. And then we need to identify a few things here. So the predictor variable in the response variable. So the predictor variable is going to be age. And the response variable is going to be the price. Okay, so again, predictor variable is kind of the input, that's your X, and the response variable is your output. It doesn't look like there's any outliers. There are, no outliers. Finally, we want to predict the price for a 3-year-old ambulance. So this is the part that I wanted to talk about. What you're going to do here is you're just going to take these values and plug in X equals 3. And so you're going to get 343.03. And so this is in hundreds of dollars. So it looks like $34,303. It wants you to round to the nearest hundred. So that's $34,300. That's going to be the price that you get there. Now, if you do need more decimal points, and there's a question like this in the quiz, if you have your data points and you need to get more accuracy, so if you, if this wasn't accurate enough, the way that you can do this is use what's called the print code. And so your print would compare Y to X, and then you'd have to specify the number of digits. So if you say you wanted 8 digits, it would run the same code and it would give you 8 digits. Okay, and so here you could get some extra data, not really extra data, but you could get increased accuracy with your code and with the, with the different formulas. So that's really all there is there. If we wanted to look for the linear correlation coefficient, this is also very easy to do. Basically, you're just going to take your data. So let's do this one really quickly. You would take 4, 5, 2, 1, 0. And Y would be 6, 6, 0, -1, -2. And then core xy is your correlation coefficient. So you would get 0.971. Oops. I said the right thing. I typed the wrong thing. 0.971 would be the correlation coefficient. And using the formula, guess what? You're going to get the same thing, 0.971. And so yeah, you get the same thing. So that's the correlation coefficient, and that's the linear regression, and that's about the extent to which you need to do anything there. Okay, so the correlation coefficient can be positive or negative depending on your data. So if I go back, let me just copy and let me show you what this would look like. So you have your X here. I'm going to go back into the ambulance question again in Y. And if you were to do the correlation coefficient, you would find that you'd have them be negatively correlated. They're highly negatively correlated. And that means that the negative just indicates that as the age of the ambulance increases, the price decreases. And so that kind of tells you the slope of the line. In other words, the change that happens is going to be in a decrease of price for an increase of age. So that's how you would interpret that. And I think that's really all there is to talk about in chapter 14. You can talk about the R squared. So if you take the correlation coefficient squared, you can obtain the value by just squaring R. So you can find again the correlation coefficient, and then sometimes R squared gets used as well. So R squared is a number that regardless of whether it's a positive or negative slope, R squared is going to be between 0 and 1. So that's a number that that you can use as well. So anyways, so that's I think all there is to talk about with chapter 14.